Hello and welcome. Today we are going to look at the second part of arrays. So let's get started. We'll create a new Jupyter notebook and let's go ahead and rename this as P6 for Python 6 arrays part 2. And in the first cell we want to import numpy as np. Okay, the first type that we are going to look today is Booleans, and in case of Booleans, let's create an array x, and it's 1 2 3 4. Okay, print x dot shape. So we have this two-dimensional array. Now if we want to compare if the elements in this particular array are greater than or less than another number, we can do that. So to do that, we can simply say y is equal to x greater than 2 if we need to check if there are any elements greater than 2, and then we can get the output of y. So as you can see, y is now a Boolean array which has the values true where the condition is satisfied for here, which x is greater than 2. 3 and 4 are greater than 2 and therefore we get the true here, whereas 1 and 2 are small and therefore we get false. Now we can use this value from y to extract values from the original array x. And to do that, we simply write x open square bracket y and close the bracket, and there you go, we get the true values from the original array x, which satisfies the Boolean condition x greater than 2. The next item, we have previously talked about this, but I just want to mention it again because it's important, is creating a copy. Now if we take this array and if we assign a part of this array to another variable, let's say in this case we are assigning the column this to y, and here if we go ahead and change the value of y to 100, and now if we print x, it changes the value in the original matrix, and that's sometimes not desirable. Therefore it's important to create a copy. Either you can create a copy of x or you can create a copy while you are doing the subset. So when you run this again, now the value of original matrix is not changed, and that's really important. Okay, moving on to another type we can do matrix manipulation is by reshaping. For reshaping, let's go ahead and create another array. So x is equal to np dot array, and this time we'll create a bit larger array, 3 4, and then create another one, 5 6 7 8, and then add another here, 9 10 11 12. Okay, print x and x dot shape. So this is our array. Now if we need to reshape, we can do that. X dot reshape, these are 12 elements, so we can say we want array to look like this, or we can say array to look something like this in one row, or we can say array needs to look like this. So there are different ways you can do the reshaping depending upon the need. The reason why we need to reshape is to align the matrices when we are doing some manipulations. There's another way we can do the x dot reshape, and here let's say we want 4 by 3 instead of 3 by 4, so we can do that as well. So these are some of the ways in which we can do the reshaping of arrays, but while reshaping, you have to remember how the resulting array is going to look, so it has to make sense, the values that are there in the newly reshaped array. We'll talk more about this in future videos, where we'll implement this in actual matrix manipulations. Now let's look at a way in which we can reduce dimensions of a matrix. So there is a function called Ravel and Flatten. So this more or less works similar to the function we saw earlier, reshape -1. So let's go ahead and copy this here. And now the difference between Ravel, so if we do np.ravel, x.ravel, we get the array flattened into one-dimensional array. So if we can print this, let's put this equal to z and then print the value of z, and also print shape of z. So it's a one-dimensional matrix. Here if we change the value of z, so let's say if we put z0 is equal to 100, what it does, it changes the value of original matrix x, as you can see here. And this is sometimes not needed. We want to keep the original matrix intact, and in those cases there is another function called flatten, and this seems we have to run the x again. Now when we run this, we can see that the original matrix is not changed in any way. Finally, there is another method to reduce the dimensions of a matrix, which is called squeeze, and this reduces the dimensions. We can use this to remove unnecessary dimensions. So let's say we can go ahead and copy the same matrix right here, and let's say this, add it there. So now it's a 4-dimensional matrix with just 1 in these 2 dimensions. So we can use the function squeeze to change that. Let's go ahead and copy this, squeeze, and it's np.squeeze. So there you go. So we removed these extra dimensions from that 2-dimensional matrix to get this one. Okay, now let's move on to another interesting topic, which is joining arrays. In here we can go ahead and create 2 arrays, np.array 1 2, and then we can create another array 3 4. 3 4 was for that part, is y 11 12 13 14, and we can go ahead and print our x, and then we can go ahead and print y. Okay, all right, we need this. Okay, so we have x and y. These are the 2 arrays that we have, and now to join these arrays, we can use a command called concatenate. So for this, we do np.concatenate. In tuple we supply the value of x and y. say provide the axis, which is 0 in this case, and we can print this. So z is equal to this, and then we can say print z. Okay, so as you can see, we have joined those two arrays on top of each other along the axis 0, so row wise. Similarly, we can copy paste this here and stack it along the columns. So this is along axis 1. Apart from this, there are other functions which is called stack. Now for stack, we can use the same code here. So for stack, we can again provide the axis value, and here you can see that it has created a 3-dimensional matrix from the two matrices. So this is 1, and then we have a second one here, and there's a third dimension as well. Similarly, we can use this to stack along columns along the axis 1. Now another way to do is column stack, and in column stack we know this is a column stack, so we do not need the axis. So here this is similar to what we saw earlier in concatenate, and similar to these there are other functions which are h stack and v stack. So in case of h stack, as you guessed it, it's a horizontal stacking similar as above, and then there is a v stack which is vertical stack, which is this, and you've already seen this earlier in concatenate. So probably have a question as to which one to use. It's up to you, depending on which you like, I guess. So these are ready-made, so h stack, v stack, I prefer these functions. Sometimes I prefer using concatenate because you can specify the axes, so it depends on the situation on which we want to use. Now moving on to the next topic of splitting arrays. Now for splitting the arrays is needed if we want to create parts from an existing array. So let's go ahead and copy our array x from top, which was this one. Okay, for splitting, and we can go ahead and get rid of these extra dimensions in here because we don't need them. Okay, so 2-dimensional array. Now simplest split we can do is np.split, and we can say x3. So here we get 3 arrays, 1, 2 and 3, and we can store them in a variable. So let's say we want to store them in 3 variables, m and o, and we can print them. Let's say this is m, n, o, this is m, n, o, and we can go ahead and print m, new line, okay. So sorry, this has to be okay. So we have 3 arrays that we have created from this array. if we want to specify axes or indices, we can do that as well. So if you go and look in help for this, we can see that we can provide either indices or sections, which is how many pieces of that array you need, and specify the axes as well. The next one is array split. So the array split helps in situations where it's not possible to create equal arrays. So for example, in this case, if these are 3, so in this case, if we tell Python to create 4 arrays, it's probably not going to be able to do that. So if we go ahead and type np.split and then type x and type 2, we get an error, and the error is array split does not result in equal division. So in such cases, we want to use array underscore split. So this creates 2 arrays of unequal dimensions, and that's the difference between split and array split. Okay, next we are going to look at vertical split. We split, and you probably guessed it. So this is again split against axis 0. So if we want to check, we can do that. So we split, and here we can see it says v split is equivalent of a split with axis 0. Okay, and here again we can give indices, or we can give number of sections. So this time let's try giving indices. We have our x, which looks like this, and let's say if we wanted to split this 2 and 3 into 3 separate arrays, we can do that. So we can say we split x, and now we can give the indices 0 1, so there will be first split before 1, and then there will be a second split before 2. So we split 2, and this should give us 3 arrays, which are like this. This is the first one, second one, and third one. Similarly, there is a horizontal split, and horizontal split would be along axis 1. We can go ahead and check that as well. So as you can see, horizontal split, okay, this is for split. For horizontal split, this will be along axis 1. p.edge split x. Now for axis, if we want to give 1, and then let's give another 0 1 2 3, so let's give 3, and this gives us 3 arrays. So this is the first one, which is first column, then the second array is 2 3, so which is this is the middle 2 columns, and then this is the last column, 4. So that's how the splits are used in arrays in NumPy. Finally, I'd like to share another way we can create arrays, which is using tile. So the syntax for that is np.tile and x. So here we can create a smaller array. So x is equal to np.array, and we give it numbers 1 2 and 3 4. Now when we are giving a function here, if we say 2 3, we are creating a tile array of these many dimensions. So we have we repeated one here and the second here, so we have repeated twice along the row, and then we have repeated it thrice along the column side. Okay, now let's talk about the final topic called broadcasting. And broadcasting is used to do arithmetic operations between two arrays of unequal sizes. So I'll explain it in a little bit more detail now. Let's create an array which is of size two-dimensional matrix. So and that's the first row, and you have the second, and we can create a third row. And we can create another array which is say 10, 20, 30, 40. Okay, print x, and then we can print y. Okay, so these are the two arrays we have. As you can see, the dimensions of both these arrays are different. So we have x, and that is 3 by 4, and then we have y, which is just one-dimensional array with 4 elements in it. Now if we were to do operations such as this, it works, and the reason why it works is because what Python does is it stacks this 10, and 40 in a vertical direction and adds it to the x. So it's similar to saying x plus y dot. So here we can do a vertical stack. So let's show this. N z is equal to np dot v stack, and I'm going to stack y. I'm going to stack y with y with y. So this is what we with broadcasting this does this automatically, and then when we add this, sorry, this has to be one less. Okay, and so if you look here, these two outputs are the same, and that's the beauty of broadcasting. Python will automatically stack the array that is smaller in size to enable that particular operation. There are different ways stacking also happens, different ways in which broadcasting happens. This is just one example of that. I can also show that if we have this array and if we multiply it by let's say another array, or we add another array to this which has dimensions of, let's say 10, 100, and this. However, we can reshape this one to having 3 columns, 3 rows and 1 column. So why don't we first create this array? Z is equal to this z. As you can see, this is array. Now we can broadcast this. So if you do x plus y, we get this answer. So Python was able to broadcast this to complete this particular operation of x plus z, and what it did was creating a stack of arrays. So this would be a horizontal stack where we have, let's say, z, 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 and z1. So it was this particular array, and when we combine this with this one, we get the same answer, which was here, and the answer is here. They both are the same. I hope you enjoyed these lectures. These were a bit long. However, it was important to make sure that the basic details on how lists work and how arrays work was important, and because these are the crucial part of how data is stored, data is manipulated and analyzed in Python. Okay, if you have any comments or suggestions, please feel free to share them in the post below. Thank you for your time, and I'll see you in the next lecture. Thanks.